Hello everybody, this is Dr. Sergey Sargasov, and today we will look into the law of cosines and how it can be used to solve triangles. This is actually a big aspect of trigonometry where students ask me, well, why do we learn, sine, cosine, these trigonometric functions? And I tell them, it's kind of like learning music initially. You have to learn the keys, the structure, right, the notes, the patterns, and then you can compose. Only then, right? It can speed up a lot of things, and it can actually expedite versus you imagine having to go, this is key 10, and then you wait for 3 seconds, and you have to then press key 16 from the left of the to the right of the keyboard on the piano. That doesn't work that way, right? You have to know the basics. And so having the basics down, now we can do some amazing things using the trigonometry, right? So let's look at this. Law of cosines, we're actually going to prove this result. It's after the law of sines that we've already learned, and you can look back at a video regarding the law of sines. But what we're going to do is we're going to draw a triangle, any triangle, any arbitrary triangle, okay? I want to place the base kind of horizontal so that it's on the x-axis, let's say, right? Like horizontal. And a lot of people, when they prove this, they actually do what? They actually kind of have this in a rectangular coordinate system. Okay, but this is not necessary. Okay, let's just say, this is maybe vertex C, this is vertex A, and this is vertex B, A, B, C triangle. And I like labeling this way because this is going to be then B, right, which is the base, kind of also, so B for base, but really B, little b, opposite side angle, big B, opposite angle A, there's going to be a little side A, and opposite angle C, there's going to be a little side C lengths, side lengths ABC, angles A, big A, capital B, and capital C. So what can we do with this? Well, let us assume we know only a few things. We know the 3 sides, let's say. We don't know anything else, okay? We don't know the heights. We don't know anything besides. Maybe we are looking for, what is that angle C? What is it equal to? I mean, if you think about it, yes, the 3, 4, 5 triangle, one of those angles is 90 degrees. And that even, we'll even look into that later. Okay, but what if it's a triangle such as a 2, 3, 4? It is a triangle, but the triangle inequality 2 plus 3 is greater than 4, right? But we have no idea, really, think about it. From all of it we've done, we have no idea what a 2, 3, 4 triangle, what angles it has inside within it. And it's not anything random, it's a special triangle, the 2, 3, 4, triangle. Okay, so now we have a triangle, ABC triangle. What can we do with this? Well, what I recommend is drawing an altitude, okay, a Chevian, that is a height, basically the triangle and altitude. It's perpendicular here and here, right, to, 90-degree angles is perpendicular to the base. And this height, call it h if you like, and then maybe this is like x right here, okay, little x, from C to this, this vertex right there that I'm drawing. I'm not going to label it. And if this is B, right, what happens, let me erase the B, and the other is going to be B minus x, right, from that vertex, let's say CD, okay, the point P, let's say CP. CP is x, well, B, then AP or PA is going to be B minus x, right, to make the whole summation of those B, which is the whole base, or, right, the side length B. Anyway, what we can do is apply the Pythagorean theorem 2 times, which we've done, in the past as far as proving it. So let's do this. X squared, you see that left-right triangle, x squared plus what? Plus h squared is equal to a squared. And right now we may not see exactly what I'm going at, but basically, look, we don't like h. It's an introduced thing, right? We just kind of arbitrarily had drawn this height. Okay, I want to get rid of the h. Remember, I'm assuming I knew the a, the c, the b. Okay, and that's it. Like you were given, like it's a 2, 3, 4 triangle, and that's all you know, and you want to find angle c. Okay, so let me erase those circles there. But anyway, look, this is true, right? It's a Pythagorean theorem applied on the left-right triangle. What are the right-right triangle? We can do this. B minus x, that other side, right? AP basically squared plus h squared will equal to what? C squared, right? Now, you see h squared in both of them? You can subtract both equations. You can substitute, whatever you like. Let's substitute, make it easier for ourselves to see. So look, h squared is equal to what? A squared minus x squared here. And over there, it's equal to what? C squared minus the b minus x squared, right, everyone? You know what b minus x squared is? If you are careful with the computation, it's equal to c squared minus, let's put in parentheses, what's b minus x squared? FOIL method it out, or multiply everything by everything. First term's b times b is b squared. Outer and inner terms combined, minus a bx minus an xb, so minus 2bx, okay? If you're confused about that, look into how to multiply out square a binomial, okay? And plus, what's a negative x, last terms, plus an x squared. And we have to subtract all of this. I'm putting in parentheses, okay? So anyway, look, what is this? C squared minus a b squared minus minus a plus a 2bx, and then minus an x squared, right? So let's now compare these right here. A squared minus x squared looks kind of like a little, not too difficult to. The expressions are kind of simplified already a little bit. And so we only have, look, we only have x, b, c, and a. Okay, well, we don't like the x, right? But let's work with it. So also, let's kind of bring this together. So look at this. I'm going to, this b squared, negative b squared, I'll put it to the left side. So now a squared plus a b squared, okay? Look, the x squareds cancel, okay? Let me actually write this equation one more time. So what I've underlined, let me write it. X squared minus x squared. I'm just going to pick those two expressions, and equals to c squared minus b squared plus a 2bx, right? Minus, you can put xb if you like. Maybe that will be kind of a good order. Xb minus an x squared. Okay, x squareds cancel. Woohoo. That's nice because something messy cancels. And we have, look, let's solve for c squared. C squared is equal to what? A squared, add b squared to the left side, b squared, and I'm kind of rotating these reflexive property, right? Reflexive symmetric property. So a squared plus b squared is more symmetric. And then minus a what? A 2xb. That's kind of like, we kind of have an equation for c squared if we knew x, a, and b, but we don't know x, right? So what can we do with x? Well, x, let's do it a little bit on the side here. When you look at x, it says, let's do this. Remember, law of cosines, and if you didn't know that, you wouldn't kind of, but look, what's cosine of the angle C? Remember, I kind of was referring to angle C a little bit. Well, we know it's adjacent over hypotenuse, and for that left-right triangle, adjacent to the side is length x, and the hypotenuse is length a. Let's solve for x. Let's get rid of like the, a on the right side. So x is equal to what? A cosine angle C, and this is almost like when we talk about the projections, horizontal and vertical projections. This would be a horizontal projection, right, of A onto the horizontal, and it would be what? The CP would become X is equal to A cosine angle C, right? Okay, so let's substitute for X, this A cosine angle C. Okay. Equals to, let's do this, equals to what? A squared minus B, plus a B squared minus a 2. That's a cosine what? Angle C. Oops, cosine angle C. Okay. And then of course there's a B there, right? And then write it like a different way. And this is actually, let me show you like another way to write it, and just a little bit more simple. Let's say C squared is equal to what? A squared plus B squared minus a 2a. Let's get the cosine C on the right side. Cosine. So 2ab cosine angle C. And what you see happening, I tell students to memorize it this way. It's a little tough still. You have to kind of memorize that law of cosines eventually. That's the law of cosines. And look, so we have c squared, opposite kind of, let's talk about this angle. Okay, so let's, opposite side squared, c squared is equal to a squared plus b squared, right? Minus 2ab cosine this angle. Okay, so it's kind of like this. Opposite is squared is equal to this thing squared, right? Minus 2 this cosine the angle. All right, that's a law of cosines, one version of it. But one we were looking for a little bit different is this law of cosines. This is it. Okay, this is a big result in trigonometry, and it's not the easiest to prove compared to some like law of sines is easier to prove, but this is an amazing result. Okay, and it's not impossible. You saw that was like a few lines of writing. Let's solve for angle C, right? Let's do that one more time. Let's do something else. Let's solve for angle C, and we will have then a law of cosines for finding the angle. This is finding the opposite side, knowing two sides. And like this is that side angle side case more so. Imagine you get a side, an angle, and a side. Then you can solve the triangle initiated in the methodology here, right? Finding the opposite side of the angle, you don't know, right? But here, you can also, let's say, have three sides. Let's say I know the C, and I only want to find that I don't know this. Maybe I want to find that. Solve for cosine angle C. What happens? Well, add to the left side the 2ab. So 2ab cosine angle C. Let's isolate cosine angle C. It's equal to what? A squared plus b squared, and then minus the c squared, right? You take away this over there, and this over there. over there. So now, divide by 2ab everything, and you have, let me show you this one. I'm also going to highlight in purple. It's going to be cosine, let me make it neater here, cosine angle C is equal to a squared plus b squared, like a kind of the touching side, two adjacent sides basically, a squared plus b squared, minus the c squared, the what is that, the opposite side squared, over the 2ab. This is even easier to remember, I believe. So remember, cosine angle C, let me show you. Cosine this angle is this squared plus this squared minus 2 this. Oops, sorry. This squared plus this squared minus that squared all over 2 this. See that again? Cosine this angle is this squared plus this squared minus this squared all over 2 10. This is hopefully something to help you remember a little bit. That's what I think when I do it. And so anyway, this is another version of the law of cosines. Same thing, right? But just a little differently written. And this will help you find the angle. So let me do an application, okay? And this is a non-calculator based application. Now, with a calculator, what do? Let's say you find, oh, cosine angle C is 0.73, whatever, right? Guess what you do? You get 0.73, you push cosine minus 1, that button on the calculator, that's the cosine inverse, or arc cosine. Call it whichever you like. It's both are the same, cosine inverse or arc cosine. And guess what you get? You're going to get whatever that angle is, in degrees if you are in degrees, of course. If you're in radians, you get it in radians. I recommend degrees for solving triangle problems. Okay? We usually care about, like the visual, oh, this is 75 degrees, this is 17 degrees. Not like, oh, this is 12 over 17 pi or 11 12ths pi or whatever that is, right? So